Good morning, all of you. Paper was difficult. Quant section, there were 17 difficult and many medium level questions. Yeah, any problem in question number 1 or 2? Please write question number. Okay, Pranjal and Amaresh. First of all, I want to explain question number 2. Yeah, this is the zoomed version of question number 2. See, what is the thing given? A paperweight is made from a glass cube of side 2 units by first shearing of 8 tetrahedral corners which touch at the midpoints of the edges of the cube. The remaining inner core of the cube is discarded and replaced by a sphere. The 8 corner pieces are now stuck onto the sphere so that they have the same position relative to each other as they did originally. What is the diameter of the sphere? So, what is the thing here? These 8 are the tetrahedral corners. This as well, and at the back of that, these are the 8 corners, tetrahedral corners. We are removing them, and the cube side is given as 2. This complete side is given as 2. So this half is 1. This is 1. So this is a diagonal thing, or by using Pythagoras, we can say this line is root 2. Are you getting me or not? Pranjal? Please confirm. Okay. See, now this is the zoomed version of this tetrahedral corner. Now, since these lengths were root 2, so this is root 2, and root 2. These lines. So at the base, we can say this is an equilateral triangle with the side root 2. Now, if I take an equilateral triangle of side root 2, root 2, let us take its center. If I join these, in equilateral triangle everything is same. We can talk about median, perpendicular bisector, anything, they all are same. So what is the formula to find this? It will be root 3 by 2 into a, that is root 2. So now we can find the, now this is what? This is circumradius. What is circumradius formula? It will be side upon root 3. This is circumradius formula. So what is the circumradius here? It will be root 2 by root 3. So if I take this as center and I join this, so basically this is the height, and I'm joining this as well. Now what is this length? It was the same length, root 2 by root 3, and this length was 1. Are you getting me? This is a question of visualization only. The complete length is 1, and this length will be root 2 by root 3. So what is this pink line length? It will be, by using Pythagoras, we can say it will be 1 square minus root 2 by root 3, its whole square, its square root. It will be 1 upon root 3. That is the height. Now this height is removed. This height is removed from 2 corners. Now what is the body diagonal of a cube? That is side into root 3. What is side here? It will be 2 root 3. We are taking side as 2 minus twice of root 3. That is the answer in this case, because we are shearing two heights from two corners. That is the diameter of the sphere. Is it okay with you? Yes, all of you? Pranjal, that was your, Amresh, that was your problem. Is it okay now? Okay, let us move to the first question now. It was a difficult one. Please go through the statement. Okay, let us see. Now what is given here? It says there are 4 vehicles traveled on a road with constant velocities, that is speed. The car overtook the scooter at 12:30. So I'm taking their positions. I'm taking their positions at 12:30. Car overtook the scooter. It means they both are moving in the same direction at 12:30. Then met the bike at 13. Car is meeting bike. It means they both are moving in the opposite direction. The time is 13. And the motorcycle at 13:30. Now these are the original positions at 12:30, and that is the reaching time, meeting time, we can say. Now I'm taking the very first line. It says the car overtook the scooter at 12:30, then met the bike at 13 and motorcycle at 13:30. Let these points be A, B and C. First of all, the car overtook the scooter at 12:30, then met the bike. Met the bike. It means AB. I'm using the formula distance is equal to speed into time. So we can say that car and bike, they are meeting after half an hour. So distance divided by time, this is equal to, since both the things are moving in the opposite direction, so what is the relative speed? That will be the addition of these two. C plus B. I'm taking the initials as their speeds. Car and bike, they are meeting at 13 and the motorcycle at 13:30. So I can say, first of all, AB is equal to half of C plus B. Now the second thing, car is meeting motorcycle at 13:30. It means the complete length AC and the total length is moved in 1 hour. This is equal to, since both the things are moving in opposite direction, so we can say this will be C plus M. That is the relative speed of these two things. So we can say AC is equal to C plus M. Are you getting me or not, all of you? Okay. Now the next line. This is my very first equation. This is second. Now the next line. The motorcycle met the scooter at 13:45. Now motorcycle is starting from C and meeting the scooter. It means distance to be covered was AC with the speed, since both the things are moving in the opposite direction. That's why I'm taking the addition. So addition will be the motorcycle met the scooter. It means M plus S, or we can say time. Now the time is, the motorcycle met the scooter at 13:45. They started at 12:30 and they are meeting at 13:45. So it will be 1 hour complete plus 15 minutes. Now 15 minutes can be written as 1 by 4 hours. So it will be 5 by 4. So the next equation is AC is equal to 5 by 4 M plus S. That is the third thing. Now the last thing. Then it overtook the bike at 14. The motorcycle overtook the bike. Now it means this distance we are covering. I'm taking BC. Motorcycle is overtaking the bike. Since both are moving in the same direction, motorcycle overtook the bike. It means speed of motorcycle should be more than bike. And the time given is 14. They started at 12:30 and they are meeting at 14. It means what is the time? That will be 1.5 hours complete. That will be 3 by 2. So what is BC? It will be 3 by 2 of m minus b. That is the fourth equation. Now by putting values you can convert. See, there are 4 variables and 4 equations. So we can do one thing. Either you find the values or convert all the variables in one variable. For example, C. Now what is the question asked? At what time did the bike and scooter met? Bike and scooter. Bike and scooter. So the distance to be covered is AB. Bike and scooter, they both are moving in the opposite direction. That's why we will take S plus B. By putting values, we can do that now. What is AB? AB is half of C plus B divided by S plus B. Now, by converting all the variables in one variable, we can put the values and get the answer. Neha, what is the problem? Are you okay with the relative speed? I mean, whenever two things are moving in opposite direction, we will add up the speed. Yes, I'm using the same thing here. Once again, I'm explaining one part only. See, the very first line says, Neha, half. Why half? Okay. The very first line says the car overtook the scooter at 12:30, then met the bike at 13. 12:30 to 13. That is half an hour. I'm using this formula. Distance is equal to speed into time. That is the relative speed, and this is the time taken by them. Half an hour. Is it okay, Neha, now? I'm calculating the time taken by them. Yeah, any other problem in this? I'm using the same concept. Okay, why 5 by 4? See, what is this thing? 3 by 2. That is the same thing, time taken. This second line, the motorcycle met the scooter. Motorcycle met the scooter, it means the total distance. That is AC. I'm writing AC here. Since motorcycle and scooter, they both are moving in the opposite direction, that's why they are coming towards each other. That's why we are taking M plus S here. It says the motorcycle met the scooter at 13:45. They started at 12:30 and they are meeting at 13:45. The complete thing is 1 hour plus 15 minutes. Now 15 minutes can be written as 1 by 4 hours. That's why we are taking it as 5 by 4. I'm using the same formula. Distance is equal to speed into time. Is it okay? In the last case, now you can understand the usage of 3 by 2. That is the time again. Is it okay, Neha? Should I move further? Okay, let us move. Yeah, it was question number 5, 8 and 9. Any problem in these questions? Okay, Abhishek, 9th question. Shubham, I'll come to your doubt after this session. I'll give you 5 minutes. I'll explain this question once again. Okay, see question number 8 first of all. How many prime numbers p are there such that 199p plus 1 is a perfect square? Not a very difficult question. What is the thing now? It says 199p plus 1, where p should be a prime number. It should be a perfect square. So I can write it as m square, where m is any integer. Now we can write 199p is equal to m square minus 1. 1 can be written as 1 square. I'm using x square minus y square formula. So it will be m minus 1 into m plus 1 is equal to 199 into p. Since 199 is a prime number, that cannot be broken. So two cases, either its value will be 199 and its value will be p, or the reverse case. First of all, I'm taking this case. If m minus 1 is 199, m will be 200 in this case. So P will be 201. P should be a prime. So this case is rejected. Why? Because 201 is not a prime number, because this is divisible by 3. You can see sum of digit. That is the divisibility rule of 3. So this case is not valid. Now I'm taking the second case. What is the second case? The reverse of that. I'm taking m minus 1 as P and m plus 1 as 199. If I take m plus 1 as 199, m will be 198 in this case. So what will be m minus 1? It will be 197, which is a prime in this case. That's why this case is valid. P should be a prime always. That's why there is only one solution. Is it okay? There is only one prime number P, and that is 197. Is it okay, all of you? Okay, now come to this ninth question. That was an observation based question only. How many hexagons can be found in the given diagram if each side of a hexagon must consist of all or part of the straight lines in the diagram? So the very first hexagon I can see is of this shape. Now if I take all the hexagons of this shape, you can see the pink one and the red one, and the reverse of these as well. I'm in this case. That is one type. You have to count only. I cannot use P and C here, permutation and combination. You have to count only. That is the only technique we can do. That's why this was a difficult question. Okay. Now hexagon's other shape will be this. Now we will count all the hexagons of these types and so on. We have to count all the shapes. I don't have any shortcut for this. Yeah, any problem in this now? Hexagon, Neha, you understand hexagon? Any polygon with 6 sides, any closed figure. Hexagon is a 6-sided figure. Okay, still any problem on this page? Question number 5. Okay, see Neha, one thing more. You said 8-sided figure. 8-sided figure is known as octagon. 7-sided figure is known as heptagon. 9-sided figure is known as nonagon, and 10-sided figure is known as decagon. Okay, now question number 5. How many integers m is? 5m plus 23 upon m minus 7, also an integer. See, this is 5m plus 23 divided by m minus 7. It should be an integer always. If this is an integer, we will try to eliminate the denominator, because P by Q when Q is not equal to 1 is not acceptable. That will be a fraction only. In integer, denominator should be 1 always. Okay, so this is a question of manipulations. We'll try to remove the denominator. What is the best technique to do that? You divide it. You can divide it directly as well. I think, Neha, you are not comfortable in algebra, so I am dividing it. So this can be written as 5 complete 58 upon m minus 7. That should be an integer. You could do it directly as well. How come? See, you want to eliminate m minus 7. You make it. I'm taking 5 as common. M minus 7. I'm trying to make. In denominator, we already have m minus 7. See, what is 5 into 7? That is minus 35. And we need plus 23. So we will add 58 to minus 35 to make it 23. We could do it directly. So now this expression should be an integer. 5 already is an integer, so this should be an integer. If 58 upon m minus 7 this is an integer, so we can say m minus 7 should divide 58. So how many factors are there of 58? They are 1, 2, 29 and 58, and their negations as well. So corresponding to every factor there will be a solution. So how many solutions are there? There will be 8 in total. That will be nothing but the total number of factors of 58 and their negations as well. Since 58 can be written as 2 into 29, so there will be 4 factors. So we'll consider those 4 positive factors as well as their negative things. Okay, so answer for this question is 8. Is it okay now, Neha? Should I move further? Okay. Question number 11, 12 or 14. 14 is a very frequent question. I've seen this question in many exams. Sometimes they have a side in common, sometimes they have exactly one corner in common, and so on. There can be many questions on this concept. Okay, 14 first of all. If you have any problem in any of the question, please write question number in the chat box. Okay, 14. 2 squares are chosen at random on a chessboard. The probability that they have a side in common. I'm taking the original question. A chessboard dimension is 8 by 8. That is a regular chessboard. I'm taking a smaller version of this. Now, it says we are choosing squares in such a way that they have exactly one side in common. First of all, I'm taking the corner squares. In total, there are 4 corner squares. Now, we want a square with this corner square, such that there is exactly one side in common. So there can be 2 choices. Either we can take this or this. So for corner square, in how many ways choice can be made? The corner can be chosen in 4C1 ways, and the adjacent square can be chosen in 2C1 ways. Now I am taking all these squares which are on edges but not the corner square. I mean these squares. In a 8 by 8 chessboard, we have 6 edge square on one edge. So in total there will be 24 edge square. So this choice can be made in 24C1 way. For example, if I take any edge square, for example this, and we need one square that has exactly one side in common. So we have 3 choices. So this can be done in 3C1 ways. Now I'm taking the remaining squares which are neither corner nor the edge square. Yes, Neha, once again. See, in total, what is the dimension of regular chessboard? That is 8. So we are leaving this corner square and this corner square. That's why we are left with 6 squares. Since we have 4 edges of a square, that's why we are left with 24 squares. From these 24 squares, we are taking one. That choice can be made in 24C1 ways. And for any edge square, we have 3 choices. Since we need a square whose one side is common, that's why you can see the blue ticks. These are the permissible squares we can take. Now I am taking the innermost squares. I think you can make it that they are 36. Now if I take this square, which is the innermost square, how many permissible squares are there? They have side 1 in common. These 4 red ticks, so it will be 4C1. What is probabilities formula? That is number of favorable cases divided by number of total cases. So these many favorable cases are there, divided by the total thing. What is the total thing? There were 64 squares. and we are choosing 2 out of them. That can be done in 64C2 ways. But this is not the answer. See, there was a twist. What was that? See, whenever you are taking any choice, for example, if I am taking this square, I mean this black one, this pair is already included. This arrow pair, that is already included. And if I take this corner square, again I am taking the same combination. So all the choices are doubled. That's why I am dividing numerator by 2. So this is the answer in this case. Is it okay with you? So it will be 4 into 2 plus 24 into 3 plus 36 into 4 divided by 2 into 63 divided by 2. That is the answer. Neha, please quote your problem. Why am I dividing it by 2? Is it your problem? The whole question, Neha, or any part? The numerator, okay. Yes, once again. Okay, see. First of all, I am writing corner squares. How many corner squares are there? 4. Then I am taking edge square, which are not corners. Can you say they are 6 into 4? And now inner squares, they will be 36. Are you okay with this, Neha? Or still any problem? I think you are comfortable. How 36? Okay. See, whenever you have 8 by 8 chessboard, so if you need innermost squares, this thing I mean, you will leave this line, this line, this line and this line. I mean the boundary you will leave. So the interior dimension will be 6 since you are removing 2 out of 8. That's why we will be left with this square and its dimension will be 6 by 6. That's why we are taking 36 squares. Is it okay, Neha? So exactly you can go by this approach as well. Okay. Now, what is probabilities formula? Probability says number of favorable cases and number of total cases. Now I think you are okay with the denominator part. I'm writing the favorable cases. I'm taking a smaller version of this chessboard. First of all, I'm taking corner square. Corner square can be chosen in 4C1 ways. I mean, you can take any one square out of these 4. If I take this corner, I need a square which is having exactly one side common. So it can be this 1 or it can be this 2. So the further choice can be made in 2C1 ways. Is it okay, Neha, now? Okay, now I'm writing the next part. If I take the edge square, for example, if I take this edge square, now the sides should be common. So these many choices can be made. Now the edge square can be chosen in 24C1 ways and the adjacent square can be chosen in 3C1 ways. Now I'm left with innermost squares. If I take this, now this pink choice can be made in 36C1 ways into, since the sides should be common, so these 4 choices can be made. That is a complete numerator, but one thing is missing here. What is that? See, whenever you are choosing this edge square, you are taking this as combination. But when you were choosing this corner square, you were taking the same combination. It means you are counting every case twice. That's why to nullify this, I'm dividing it by 2, the numerator part. Is it okay now, all of you? Okay, let us move. Yeah, still any problem in question number 11 or 12? The year 1789 has 3 and no more than 3 adjacent digits, 7, 8, 9, which are consecutive integers in increasing order. You can see here 789, they are the consecutive integers in increasing order. How many years between 1000 and 9999 have this property? We need 3 consecutive integers. The choices can be 012, 123, 234, 345, 456, 567, 678, 789. That's it. And our range is this. It means we can talk about all 4-digit numbers. So, first of all, I'm taking these cases. First of all, I'm taking 234. Now we need a 4-digit number. It can be 234n, since we need this order only, 234 in increasing order only. It can be n234 as well. Now this n can be 0 to 9, anything, but 5 is not acceptable here, since we need exactly 3 digits in increasing order. So we cannot take 5. So how many choices can be made from this? There can be 9 choices. Plus, now I'm taking the second case. For this n, 0 is not acceptable as well as 1 is not acceptable. That's why how many choices are left? They are 8. So for these cases, for every case we'll get 17 cases. Now I'm taking this case. The choice can be 789n or n789. Now this n can take any value from 0 to 9. So there are 10 choices plus this. Now this n can take any choice except 6. That's why there are 9 choices. So for this case, 19 choices are there. Are you getting me or not, all of you? Okay. Now I'm taking the very first case, 012. 012n will give you a 3-digit number, so not permissible. I'm taking the another thing, that will be n012. Now this n can take any value from 1 to 9. Of course, we cannot use 0 at extreme left. So how many choices are there? There will be 9. Now we are left with this 123 thing. For this 123, how many choices we can take? N cannot be 0 here. That's why how many choices? 9 plus. It can be this way as well. 1, 2, 3, 9. 1, 2, 3, n. Now this n can take any value except 4. So these 9 choices. Now you can add up all the things. You'll get the answer. Is it okay, all of you? That was a question of counting only. Okay. Swar, you said question number 12. Question number 12 was easy. You should draw the figure of this. It says, suppose circles C and concentric at the point O are drawn in such a way that line P and n plus 1 is of unit length and is perpendicular to OPN for every n this and this. Okay. See. Two circles are given. First of all, I am taking 2. And so on. I am taking the innermost 2 circles. All of them are concentric. You must know the meaning of concentric circle. Let it be their center. So what is the thing given? it says you are taking any point. Let this the innermost circle is C1, then the second circle is C2, and so on. So this is C1 circle. You are taking any point on this. Let it be P1. You are joining this. Now you are taking any P2 point on C2 circle. I mean the second circle, such that P1, P2 is of unit length. So I can take this. Let this point be P2, such that P1, P2 is of unit length. And one thing more, this P1, P2 is perpendicular to OP1. So P1, P2 will be nothing but the tangent to the C1 circle. Is it okay, Swar? Are you getting me? Okay. See, now we want to calculate the areas between these regions, between these circles. Okay. What is the area formula? It will be pi r square, pi into radius square. So we will find the radius of every circle. I'm taking C1's radius as r. So what will be the C2's radius? I'm using Pythagoras in triangle OP1, P2. In this, we can say since P1, P2 is perpendicular to OP1, so OP2, that is the radius part, new radius. This will be square root of OP1 square plus P1, P2 square. OP1 is say r and P1, P2 square is given as 1. So we can say what is the new radius? It will be r square plus 1 square. So I can say, if I write all the squares, circle sorry, and square of their radius, it will be r square. It will be r square plus 1. It will be r square plus 2. It will be r square plus 3, and so on. So now we can find the area, required area. First of all, I am counting this. That will be S2. I think that is S1. S1, yes. Yeah. What is S1? That is C2's area minus C1's area. That will be nothing but subtraction of two areas. So it will be pi r square plus 1 minus pi r square. So in every case, we'll be left with pi. So if I take any annulus, I'll get the same area. Pi will be the area always. So now you can take the subtraction part. Since all the areas are same and number of terms in every expression is same, that's why what is the answer to this question? It will be 0. Is it okay, Swar? That was a question of construction only. Is it okay? I need your confirmation. Yes, very good. Yeah, any other thing? We have done all the questions. Okay, tell me one thing. Question number 14. If I replace side by corner, you can take this pink thing. What should be the answer then? Please write the numerator. Don't solve it. Write the expression only for question number 14. If I replace the side word with this corner, exactly one corner. Okay, Shubham, please write numerator for me. Yes, any one of you? So it will be for corners once again 4c1 into 1c1. For edges it will be 24c1 into 2c1. Plus for innermost square it will be 36c1 into 4c1. With the same logic, we'll divide it by 2. Not 36c4 Swar. Okay, I'm leaving it here only. You can verify. Now come to this. It was a difficult question, a good question on geometry. Yeah, any problem in this? Question number 22. Any problem? Yes, of course, Neha. But you should concentrate on easy and medium level questions. Okay, see now, Preet. We have a square of side 20 each. Now two figures are made. One is regular octagon and one is a 12-sided, which is called dodecagon. What is the difference between the area of the dodecagon and the area of the octagon? So I'm taking a square. First of all, we'll make an octagon. Before explaining this, let me write the formula for if I take any regular polygon, what will be the interior angle formula? It will be n minus 2 into 180 divided m by n. So in case of octagon, that is n is equal to 8, it will be 6 into 180 divided by 8. And in case of dodecagon, it will be 10 into 180 divided by 12. Now you can do the calculation part. It will be 135, and in this case, 12 case, it will be 150. So first of all, I am taking the octagon thing. I am making a cut here. Now this is the octagon. Yes. Okay. Now this angle is of 90 degree. Yes. Since this angle is of 135 degree, or we can say one thing. Let it be x. Let it be x. So this length will be x root 2. If this is 135, this angle is of 45 degree, and you know, if I take this triangle 45, 45, 90, the side ratio will be 1:1 root 2. The total side was 20, x is out from here, x is out from here, so this length will become 20 minus 2x. Since we are talking about a regular octagon, the side length always should be same. So we can say this 20 minus 2x, I'm taking this line length and this line length. 20 minus 2x should be equal to x root 2. From here we can calculate x value. It will be 20 upon 2 plus root 2. We can rationalize it. It will be 20 into 2 minus root 2. I'm leaving the calculation part for you. It will be 10 into 2 minus root 2. Now you can write the octagon's area. Octagon's area will be square area minus 4 times triangle's area. You can do it now. Now I'm taking dodecagon. Now dodecagon is made in this way. Again, a cut is made. And so on. Now what is this angle? It will be 150 degree. So this remaining angle will be 30 degree. I'm using the linear pair thing. On a line, the angle made is always 180 degree. I'm taking this square. Let square length is x. Now whenever we have 30, 60, 90 triangle, you should remember this. What is the sides ratio? It will be 1:√3:2. So in front of 30, side length is x. In front of 60, the side length will be √3x. And in front of 90, it will be 2x. Similarly, 2x here. So the total length was 20. So the dodecagon length will become 20 minus twice of, since we are taking on either side 2, twice of x plus √3x, and that should be equal to the side length, that is 2x. Now you can get the value of x here, x from here. Now I'm writing the area. Area will be square area minus 4. I am taking 4 times, since there are 4 corners. It will be the square area plus 2 triangles, half into base into height I am using. Now you can put the value of x, you will get the answer. Since you have calculated octagon's area and dodecagon's area, we can do the subtraction part. It was a calculative question. Okay, now come to, I think, is it okay with you, all of you? It was avoidable, of course, calculative. Now the next thing, easy one, seems difficult. Yeah, any problem in this? Yes, of course, for if you can visualize this, this was an easy question. Should I move further? Okay, I'm leaving this question. Yeah, 24th, easy again, Venn diagram question. Yeah, any problem in this question? Please write explaining chat box. I'm leaving this once again. (28) geometry again. Should I move further? Okay, good. You can read the explanation part. Nice explanation is given. 41st, very long question. Any problem in this? Should I explain this? Pranjal and Apreet? Okay. See, you must have read this question. I am taking the options only. See, you have a revolver, and I'm taking the very first option. See, Gabbar places 2 bullets into a 6-chambered revolver in successive order. I'm making a diagram of this to understand. See, there are 6 bullets. Let me do it once again. These are the 6 bullets. Suppose it is revolved in the clockwise direction. You can take any direction. We'll get the same answer. It says Gabbar places 2 bullets into a 6-chambered revolver in successive order. If I am putting a bullet here, so these are the empty places, and it is moved in the clockwise direction. He'll spin the chamber, close it and take one shot. If Samba is still alive, then he will take the next shot without spinning. It means we are getting two consecutive places. If I take two consecutive places, I'm starting with this one. It can be bullet, bullet. I'm going into clockwise direction. Are you getting me, guys? It can be bullet, bullet. It can be bullet, empty. It can be empty, empty 3 and 4. Then it can be empty, empty 4 and 5. It can be empty, empty 5 and 6. Then it can be empty, bullet. These 6 cases are possible. He said he'll spin the chamber, close it and take one shot. If Samba is still alive, it means at first shot there was no bullet. So these 4 cases are permissible. These 4 cases, they are permissible. And we want to calculate the highest survival chances. It means Samba is still alive after the second shot. So these 3 cases are favorable. So what is the probability of first case? It will be 3 by 4. After the first shot, we know the first place was empty. That's why these 2 cases, first 2 cases are gone. Now we need second shot is also empty. That's why we are getting 3 favorable cases. So what is the probability? That will be 3 by 4. That is 0.75. Is it okay? Are you okay with this? If you are okay with this, rest of the question will be easy. Now I'm taking the second part. Gabbar places 2 bullets into a 6-chamber revolver in successive order, the same thing. He'll spin the chamber, close it and take one shot. If Samba is still alive, it means he is getting still alive. Then he'll spin the chamber again before shooting the next shot. What will be the probability of this? Samba will spin the chamber again. It means any place can come. It means what is the probability of second thing? It will be 1 by 6. First shot and second shot, they will be independent. Now I'm taking the third thing. Gabbar places 2 bullets into a 6-chambered revolver at opposite ends. Now the places are different. Say here is a bullet, empty, 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 empty. Now you can write once again all the cases. You can go into a similar case. So we need higher survival chances. In first only you will get 0.75. That's why first option, this is the answer. Is it okay with you? All of you? Okay, I'm moving further. Okay, what is the answer for this? Any problem? Any problem in 42nd question? Any one of you? Since I'm getting no response, I'm skipping this question. Swar, okay. Should I explain this? 42nd, okay. Swar, lovely. Consider a positive integer x. This range is given 1 to 100. What is the difference between the maximum and minimum values that x can take so that x squared plus 4 and x plus 3 have a common factor greater than 1? It means their HCF should be more than 1, that is not equal to 1. Let this be anything, say y. What is the meaning of f in HCF? That is a factor. If I consider y as a factor of these two expressions, it means y will divide x squared plus 4, y will divide x plus 3. See, I want to comment upon y's values, so I'll try to relate y and x. see, if y is dividing x plus 3, of course it will divide x plus 3 its whole square as well. Now y is dividing x square plus 4 and this. Of course, if y is dividing both these expressions, y will divide their subtraction as well. What is the usage of this? We want to eliminate x square. Step by step, we will try to eliminate x so that we'll get a constant value. And by that constant value, we will write all the values of y. Now, y is dividing x square plus 4 and x plus 3 whole square. What is x square plus 3 whole square? This is x square plus 9 plus 6. If y is dividing both these expressions, y will definitely divide subtraction of these two. So what is subtraction of these two? It will be 6x plus 5. It means y will divide this as well. Now I want to eliminate this x. So I'm combining these two things. Y is dividing x plus 3 and 6x plus 5. Of course, if y will divide x plus 3, y will divide 6 into x plus 3 as well. Again, this is a manipulation only. I want to eliminate x. If y is dividing 6x plus 3, that is 6x plus 18, and y is dividing 6x plus 5 as well, y will divide their subtraction. So, what is the subtraction part? Y will divide 13. Now, here is the thing. If y will divide 13, it means y can take any value which is a multiple of 13. So, it can be 13, it can be 26, we can go up to 91. Accordingly, we will take the value of x. Now, y was dividing x plus 3 and y is dividing 13x well. So, x can take either 10. You can add 13 to that. X can take 23. X can take 36 and so on. Now you can calculate all the values in this range. X plus 3 swar replace x in 6x plus 5. X plus 3, 6x plus 5. How did x plus 3 replace? Okay, see what is the thing. Once again, Kenny says for if y is dividing anything, y will definitely divide its square as well. So I took square of that. Now y divides x square plus 4. Y divide this expression as well. So y will definitely divide its subtraction. That's why if I take the subtraction part, it will be 6x plus 5. I'm trying to eliminate x. Now I'm taking this. Y is dividing 6x plus 5. Y is dividing x plus 3 as well. To eliminate x, if y is dividing x plus 3, it will divide 6 into x plus 3 as well. Already it is dividing 6x plus 5. If y is dividing a and b, y will definitely divide a minus b. So we'll take the subtraction part. It will be 13. That's why we are taking this. Is it okay for now? Okay, let us move. Nice question it was. Normally avoidable. 44 to 47. Swar, I'll give you 5 minutes extra after the session. 32 I'll explain. Very frequent question. You can see these type of questions. Standard approach we will follow. I'll explain it later. First of all, I'm trying to cover all the difficult question. Question number 44 to 47. There was not a difficult concept. Actually, calculation was difficult. It was a calculation based set only. Any problem in this? Not the conceptual problem. I think you can manage it. Okay, I'm leaving this. Okay, now this set was really difficult. And you can see these are the last 4 questions. Okay, any problem in this? Very lengthy, actually very lengthy. Avoidable. AR was very easy otherwise. If you skip 97 to 100, AR was easy. Conceptually it was easy, but information was lengthy. See, yes, additional information was very lengthy. That's why. Okay, Pranjal and Kashish. Yes, Pranjal. It was a lengthy set only. That's why I'm saying this was avoidable. Otherwise, AR was very, very easy. Sitters only. Please go through the explanation part. There is no shortcut for this. Yes, Pranjal, of course, you can see these many questions, these lengthy questions in paper 2. Okay. That was the last set we were discussing. Now coming to your problem. Okay, Swar. Yes. It will take 15 to 20 minutes if you are good at AR. Now I am coming to 32nd question. It is a very standardized question. See what is the data. Whenever you see this type of question, I think in Bullcat 1 or 2, we had almost the same question. It says 49 raised to power x, 49 raised to power x plus 7. That was the thing. And the answer was, I think, 833. Almost a similar question. Data change. Whenever you see this type of question, you can see we are putting 4 and square root of 4. The same was the story in another question, 49 and the square root of 49. Whenever you see this type of question, you calculate f of 1 minus a. It will be 4 of raised to power 1 minus a, 4 raised to power 1 minus a plus 2. It will be 4 upon 4 plus 2 into 4 raised to power a. I'm leaving the calculation part. I'm not going to explain this. If I add these two, this will be 1 always. That is always true. Whenever you see this type of question, this is always true. So now I'm taking the expression. Expression was f of 1 upon f of 2 upon 1999 and so on up to f of 1998 upon. See, whenever the input sum up to 1, the total will be 1. So if I take first and last part, it will give you 1. If I take second and second last, it will give you 1. It means you are pairing them. How many terms are there? 1998. How many pairs can be made? It will be 1998 by 2. And corresponding to every pair, you are getting 1. So this is the answer. Exactly this approach you will follow. Yeah, any problem in this now? Answer will be same always. Always answer will be same. That will be the total number of terms divided by 2. Okay. Yeah, still any problem you are left with? I think somebody was asking one question. I'm not getting that. Yeah, still any problem? 30th. I don't have data for this, Swar. I think you can read the explanation part. Shubham, you were asking. Yes. Got it. See, if you are overtaking someone, it means you are going in the same direction. And if you are meeting someone, it means both the things are coming from opposite direction. That's why I took opposite direction. Is it okay, Shubham? You can read the language. Overtaking means you are going in same direction. Yes, 27th. That I can tell you. I think you are confused in that word, head start. So what is your problem here? See, there is a 320-kilometer race between Mr. Grover and Mr. Mohinder in a river stream. Let the stream's speed be is kilometer per hour. They are moving in either downstream or upstream direction. Speed of Mr. Grover is twice that of Mr. Mohinder. I am taking Mohinder's speed be m. So Grover's speed will be 2m. I am taking all the data into kilometer per hour since 320 kilometer is given. Okay, all the answers you can see they are given in kilometer per hour. See, now the main line. It says maximum head start he can give Mr. Mohinder is 70 hours. See, head start is of time here. It means you are giving advantage to someone. You can move in either direction. If you are giving the maximum head start, it means you are at the opposite end points. Suppose this is the river stretch. Let it be Mohinder and it will be Grover here. It says maximum head start he can give Mr. Mohinder. So it means Grover is moving with the flow. Already Grover's speed is double of Mohinder. So he'll take less time. And he is giving the maximum head start. It means what? He'll be taking the least time. So he'll be moving in the downstream. And Mohinder will move in upstream. So 320 divided by 2m plus s. That is the time taken by Grover. And he is giving head start of 70 hours. It means he is taking 70 hours less. And Mohinder is taking, plus 70. Mohinder is taking 320 upon upstream thing. Now you can solve it. You can write the second equation as well. No, sir, this is not mentioned. Are they racing in the same direction? It's in bracket. You can see not necessarily in the same direction. That's why he has taken the word maximum. Is it okay now? If maximum head start we are taking, so we will try to minimize this. The time taken by Grover. We'll try to minimize this. So we will try to maximize the denominator. Already his speed is 2m. So if he move in downstream motion, he'll take the minimum time. That's why. Is it okay now? Okay guys, that's it for today. Difficult paper it was. Okay, and one thing more, once again I tell you in every session, whenever you come for analysis session, please go through the paper. Okay, thanks a lot all of you.